So pitch class. Yeah, I would like to review how we build them and how we invert them and how we find the normal form and how we find the prime form as well. Yeah. So a lot of maths. Okay, a bit of maths. So let's get in the mood of maths. So basically, go one by one. It's something you need to learn to understand well the pitch class sets, which are two elements we need to work with. One that you already worked with, the pitch class set itself, and another one, the interval class vector. That is something that you haven't seen. Yeah, so I have to introduce you to that as well. So the pitch class sets. Well, we know that what is a pitch class? Who can say what is a pitch class? No one?
Interval.
No, it's not an interval. Not an interval. No. A pitch class is a number that defines all enharmonic occurrences of the same pitch. Why is it called pitch class? Because 0, that is C, is also it is also D double flat, right? It is also B sharp. All of it is 0. Okay?
Yes, what do you call, what do you call a semitone and a tone? What are they? Because they're not intervals.
They are interval classes.
Okay.
But we will go, that's why today I want to clear that up for you. Yeah? How they relate one with each other. So, pitch class is that. That's why it's called a pitch class. Because in the common harmony, we also have classes. Because C is C1, C2, C3, C4, C5. Yeah, it's always C. So in that sense, it's a class of C. Right? But D double sharp, right, and B sharp is still a different thing in common harmony, because common harmony also covers the point of how we resolve, because it's taking everything from a perspective of tension and relaxation. Yeah, but in the pitch class it's a bit more, it's drier. It's not so much concerned about tension and relaxation and all the cultural implications of the common harmony, right? It's just the notes, yeah? So then we don't need to say in the pitch class, in the set theory, we don't need to talk about B sharp and D double sharp. Yeah, we need to talk about 0, which is always the same note in the keyboard, even. Yeah, 0 will be always the same thing. And then C sharp will be 1. And D will be 2. All right. Okay. So, and we are exploring obviously the prime form. The prime form. We are exploring the pitch classes themselves. Exactly. So then, the pitch class is the number that defines all the occurrences of a key in the keyboard. For example, if you want to remember it like that, on a more objective way. Yeah. It's more about naming the material keyboard. Key in the keyboard rather than the pitch, because if we actually think about the pitch, I have always a criticism of this theory, because in the violin C sharp it's not the same as D flat. Yeah, C sharp is sharper than D flat, which is flatter. Yeah, which is maybe C sharp tends to D, doesn't tend to C, and D flat tends to C, doesn't tend to D. Right? So in that sense, they are different, but in the set theory, they are not. It's a simplification of the pitch occurrence, actually, which is great for the keyboard, but not so good for the string instruments, I guess. So, anyway, we are going to continue. And then we can have a pitch class set. Pitch class set. So, for example, if we have this and that, what sort of pitch class set do we have?
Five. 0, 5. If we start with 0.
You are giving me the prime form, which is great, because actually you always have to think like that. But just describe precisely what is there, not the prime form.
Now you lost me.
Yeah. I taught you the other time to always go back to the prime form. But this time, I want whatever is written there. Yeah? So, it is E is 1, 2, 3, 4. Yeah?
We will start on C.
Yes, exactly, because I want the pitch class set objectively. The reason I taught you the other way like that is because when you compose, you will always work with the prime form. So I just did a shortcut. But now I would like to cover the gap. Yeah, so because it has certain enrichments that actually might be of use. So then 4, and then what's the next one?
9.
Precisely. 4 and 9. The interval class between them is
5.
Yes.
Semitones. Or
it's 5. It's 9 minus, yeah, it's just 5. That's the interval class. Yeah. All right. Now you will see why I taught you directly the prime form with the following example. Right? So let's see that you have this. What is the pitch class set of this? Sorry, I will give you a better one. What is the pitch class set of that? Yes, Georgios.
5, 7.
5 and 7. Precisely. And what's the pitch class set? The interval set?
2.
2. Okay. We're going to continue with another example. What's the pitch class of that? Georgios.
9. 4.
Yes. So what happens here is that the maths don't work straight away. Yeah. So if we do 4 minus 9, we would have minus 5, which doesn't make any sense. Yeah. For you and me, it does make sense because we know what it means. Yeah. But to give you a clean procedure, yeah. Basically, you need to think about like the hours on the clock. The hours on the clock. So the hours on the clock, they are always 12. Yeah. So what you will do is to add 12. So you have 9 and 16. So what's the interval class?
7.
That's it. 7.
12 semitones. You see?
You see? So we keep it always like this. All right. Okay.
Is minus 5 a thing?
No.
We don't have a way to label inverted intervals.
No, because the whole idea of the interval class is that they mean the same, and I will go on that now. Yeah. So we will use them, but they have to mean the same. I will go a bit on interval class, so I clear up that interval class. The interval class is not the pitch class. The interval class. There are only 6. There are only 6. And what do you think is the middle point?
Tritone.
Yes, it is a tritone. Precise. So interval class. 0 is the octave. 1 is a semitone. 2 is what?
Tone.
Tone. 3 is.
Should I say?
Yeah.
Actually, I don't know how to say it.
You can say it in any way because it doesn't matter. Just choose the easiest one. Now, let's see if your power of simplicity. Choose the easiest interval to define 3.
Minor third.
Yeah, thank you. And then 4.
Is there no word in English for triple semitone?
No. Well, you can say triple semitone.
Sorry, different topic, but in the harmonic scale, we say tone, semitone, tone, tone, semitone, triple semitone, the augmented second. How do you call that?
Augmented second. Yeah, I know what you mean. Yeah, it's like a tone and yeah, but there is no word for it. You can say triple semitone or dotted tone. No, it's just it's basically it's like there is no precise. You can say triple semitone. I would say triple semitone confidently. It says what it has to say. So I would call 4 major third and then
perfect fourth.
Perfect fourth, and then tritone.
Yes.
Right? And that's it. Those are all the interval classes we have. An interval vector will actually be that. Yeah, an interval vector will only describe the occurrences of these intervals within a pitch class set. And this all the most important. Who can tell me why is all the most important in a theory like this one? Why is all the most important thing? The intervals vector. Because the whole idea of the pitch class sets, the whole idea. Let's say girls. Yes.
What is that term? Interval vector.
Interval vector is interval class. So it describes all the occurrences of the density of the interval class within a pitch class set.
No, I don't get it. What is it again? I don't get it. Sorry.
Okay, no worries. I go myself. Look, we said the pitch classes is our way to name notes with numbers, right? Then the first time I taught to you about pitch classes, I automatically told you to go back to the prime form, basically, so to not do them in the air, as we say, no? So to never start with 7 or 5, or always start from 0. There is a main difference between a pitch class set and a chord, is that a pitch class set is only concerned about the intervals, objectively. There is nothing else conditioning the way we think about the notes, but the numeric expression of the notes itself. Yeah, it's not about the sound, how we feel, it's about the notes themselves. It's a very dry approach. Yeah, so it's not about the intervals. Therefore, the most important thing to know about any pitch class set that we choose is the different density of those intervals, because by all means that's what's going to be the character of the pitch class set. For example, if we have a pitch class set that has no thirds and no fourths and no fifths, we have to that we have an idea of how a third sounds, and we have an idea of how a fourth sounds, and we have an idea of how a fifth sounds, right? And a tritone and a semitone. So if we know how much of those colors we have in the pitch class sets, we actually know how overall, yeah, the music is going to sound. It's going to sound more tonal, maybe, or it's going to sound more atonal, or it's going to sound sharper, or it's going to sound rounder, or it's going to sound more mellow, or it's going to sound more icy, and all sorts of very subjective appreciations that we can do of a pitch class set, which makes no sense whatsoever, but inside our own system of beliefs and and perception of the intervals, which is very liberating, actually, if we take it in that way. We finally arrive to a point in which we can make them of a use for ourselves within our preferences. Yeah, we can create a pitch class set full of major thirds, for example. In that sense, pitch class set doesn't marry for life, yeah, the feel of free atonalism. Yeah, it's not married for life with that sort of quirky, not necessarily. I mean, it depends on what pitch classes you put in there, right? It's under your control at the end of the day. So I did a parenthesis on that, and I will go back to pitch class again, yeah? And I will tell you how to invert them, because now you need to advance a bit further, yeah, in the art of inverting the pitch class sets, yeah? There is something that we didn't discuss, which is, one is the normal form of a pitch class set, and we are going to go on that now. The normal form. The normal form is the simplest, smallest form of a pitch class set. Simplest, smallest form of a pitch class set. Normally, we calculate that one prior to bring it down to the prime form, yeah, which is something I did a bit of in a per saltum, yeah, just to allow you to do the first exercises, but now I need to refine it, yeah. So, because we are not going to bring to the prime form things that are not the normal form to start with, yeah. So, let's start all over again, right? So, we will avoid inversions in the pitch class sets. The normal form will not have inversions. The normal form, inversions of the pitch class. So the 10th, for example, is an inversion of something else. Of what?
3. It has to be. 13 minus 10. It has to be.
No, you're not right.
1, 2, 3, 4, 5, 6, 7, 8,
Because
9,
it's not
10.
13 minus 10, it's 12 minus 10.
Yeah, but why?
It's always 12. It's always 12 because we always consider number 12.
You're right. I'm wrong.
Yeah. But the methodology was correct. The methodology was correct. It was 10 and 2. Just a typo there, a mental typo. Okay. So
Come to the first as unison first.
yes.
But it's not 0.
Exactly. So then, look, we're going to do something. I want to give you one that is very easy to actually. That's it. Okay. It is. I know that you don't like maths a lot, but I will have to ask you something. We can't leave Georgios to do all the lesson. Eh? So let's see. What is the pitch class of this?
So D is 0 or D is 1?
No, just say what you see. This time say what you see.
I mean, if C is 0, then D is 2. So I would say that's 2.
Yes, very good.
And then 5.
Yes, 5.
And then 7.
Let me change the last one so I make it easier. Just 1 second. Sorry. Yeah. That one?
10.
Yeah. Yeah.
But
11. 11. Okay, very good. So, a normal version is the version that shows these notes with this, first of all, with the smallest outer interval. So, what's the outer interval of this? Laura.
9.
Yes, precisely. Thank you, Laura. So now we're going to do the first rotation, which is also a sort of, is an inversion in this case. So it will be like this. Georgios, what's the outer interval?
5 to 14.
So let's name it first. So what's the pitch class set here? 2.
14. I have to think. 2.
Okay, and then here is 5, right?
Yeah. So it has to be 9.
No, here is not 5, sorry. What is here? Here.
What? Here, there. 7.
7, that's it. So then, plus 12.
But from F or from G?
Sorry, I did it wrong myself. From here. So what is this interval? 5. Yeah, I did it first. I did it right first time. Yeah, I got it. Okay, so what is this?
14.
Precisely. 14 minus 5. What's the interval?
Oh, I see. Yeah, 9.
9. All right. And then we rotate it again. So we do Sol, Si, Re, Fa. Okay. Again. Nervios. 7, 11. 7,
Me?
11. Yes.
11 and
2 and 5.
5 and 2. 17, 10 is the interval. The space, how you call it?
The outer interval, but this is not just 1 second. So we on Fa, now on Sol, Si, Re, Fa. Yeah. So Sol, Fa. Exactly. So what's the outer interval? 10. Very good. And then, well, we can do another one. Let me just delete this one. No, we'll delete that. All right. That's it. Okay, so Re, Fa, Sol, Si. Re, Fa, Sol, Si. And then we do go from Si. So we do Si, Re, Fa, Sol. So what is this one? Obviously, it's going to be 11 and then
7.
no.
Yeah,
Si.
I'm doing it. 11, 2, 5, 7.
11, 2, 5, 7. Okay, so then plus 12, 19 minus 11, how much?
8.
8. So what have we found? What have we found? We found the normal version. Right, we found the normal version, the version in which these intervals are gathered, yeah, within the smallest outer interval. Yeah, so this is the shape we are interested in. Okay. All right. So that's what we're going to call the normal form. Now we need to bring this. To the prime form. Who can do it for me? So basically, what are we going to do to bring it to the prime form?
So consider B the tonic, the center there.
You have to consider this one. So that is C. So C is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah? So it's your new 0. Right? So then, minus 11 on Re, which is a 2, you can't. So plus 12. 14 minus 11.
3. 3. Yeah, 3.
No, just 1 second. Precisely, yes. Then, this one. Plus 12 minus 11.
5 plus 11 plus 12, 17. 5 plus 1, 6.
Yes, 6. Sure.
Yes. Plus 12 minus 11 is just plus 1.
Exactly. Very good. And the next one?
8.
8. Very good. Well, now we have a prime form. Right? Now, this one, has an issue. What's the issue?
They are above the triton.
Exactly.
No.
It's above the threshold. It's above the threshold.
6 is no.
Yeah, because the pitch class sets that we will consider, is it above yeah, it is or not? 1, 2, 3, 4, 5, 6. Yes, it is. Yeah, we need to make sure that is within the frame of, so we can create the vector afterward. Yeah. So we need to fix that. So to fix that, there are several ways we can fix that. So basically, we can just turn it around. Yeah. We do 3, 6, 8, 0. Right? We bring it down again. We have 0, 3, 5, 12 minus 0 minus, plus 12, so 12 minus 3 is 9. Yeah, we have the same issue here. And then what we can do, the shortcut to do this is to just find to do the inversion. So 12 minus 8 is 4, right? So then we just have 0, 0, 3, 6, 4. Right. Now, if we do this, we can see that we might not have. 1 second. Yeah, we should have the biggest interval here, and we don't have that one. Yeah, we don't have the biggest interval there. So 3, 6, 18, 3, 6, 3. 1 second. 1. Problem is this one. So we need to get this one in the end. So 3. This one is 6, is 3. This one is 2, then we will invert it. So what we can do as well is this. That's it. So basically, we can move it around and we keep the same interval classes. We keep the interval classes, but we have the smallest expression, yeah, of the of the pitch class set.
How can we make 8 into 4 into... How can we make 8 into 4? It changes the pitch class.
Because 8 is an inversion of the fourth.
Yes, but it will be a different note.
Yes, the other way you can do it, it will be a different note. Yes, I know, but the important thing is the interval. The priority is the interval, not the note itself, just the interval that exists between the notes.
Okay.
And normally we should have, to have a good pitch class set, we should have the intervals like this. So from smaller to bigger. Right? So we can order it in that way, for example. So then we have 0. And then you get the prime form. Now, when you have the prime form, finally, then you can actually, let's talk about a prime form.
But I don't understand. Why did we do the whole inverting to the smallest if we could just not invert, how do you call it?
No, because we are seeing it in the perspective of the analysis, not in the perspective of the composition. That's why when I taught it to you, I said, do it from 0, because then you can transpose it. But this is good if you see it in a piece. For example, if you're analyzing a piece of Alban Berg probably will not find the prime form for many different reasons. So then you can actually try to get to the prime form following the steps, and then see how he manipulated the prime form. So this was all under the perspective of analysis. Now I will go back to the perspective that really concerns us, which is the perspective of the composition. So let's say that we go on a pitch class set, which is 0, 3, 4, 6, for example. 0, 3, 4, 6. Actually, I will express it in the best way possible, which is 0, 2, no, it's fine. It's fine. I will do that. 0, 3, 4, 6. 0, 3, 4, 6. All right. So now we have to see how many intervals we have of each kind. No? So we have IC1, IC2, IC3, IC4. I will just do it again. IC1, IC2, IC3, IC4, 5, and 6. Okay. So then, what's the interval we have here? 3 minus 0. We have one of this one. Then this one of this one. I will do these ones quickly. This one of this one. Right? Now, of this one, Georgios?
1.
That's it. Of this one?
3, another one.
Okay. Of this one? 2, 1. So the interval vector of this will be 1, 1, 2, 1, 0, 1. Okay. The interval vector will be great because then, thanks to this one, we can really see the coloring of the piece. We will see that we are going to have almost all the intervals with a preference actually on the minor third. Okay, we will review this next week again, right? And now I would like you to explain all the ways that you can actually invert an interval. So what you can do with an interval. With an interval, you can do several different things. For example, let's go for, again, 0, 3, 4, 6. One thing is rotating it. You can have 3, 4, 6, 12, and so on. Yeah, in all the different forms. In the composition now, when you are writing. Okay? You can also go backwards, right? So you can go 0, 3, 4, 6 in the score downwards in pitch. So instead of, because it's the same thing, going to C to D or C to B flat. Sorry, C to E flat and C to A, right? It's the same thing, C to E flat and C to A. So a normal proper pitch inversion is also an option. Okay?
Wait. Can these glass sets, no, these pitches be considered also the inversions of them, some going up, some going down. So 0, 3 up to 4 up, 6, no, 6 is a bad choice. 0 to 3 up, 4 down. So C, E flat, and then instead of E natural, you go down.
You can. Yes, I know what you mean. I know what you mean. So you can go. Let's go on Do. 3, 0, 3, 4, 6 can perfectly well be. So 3 and then. Yeah, and then another thing, right?
The tide. Let's check. Then it's chaos. Then a number of
Yeah, but look, you can do whatever you like with them, yeah, in as far as you do for example, the inversions. Let's bring it to maths again so I don't lose you. So I have C. Then you can use E flat or 12 minus 3. 12 minus 3 is
La.
Exactly.
E natural.
Then you can use E natural or 12 minus 3.
Oh. Okay.
Yeah. And then you can use F.
Then that has a
Sharp.
Then,
Or 12 minus 6.
how do you call the previous one that we saw?
Again?
How do you call the previous things that we saw? What we labeled 1, 1, 1, 2, 1, 1. How do you call it?
The interval vector. Yeah.
Then if we consider them inverted, they will be different. There will be more.
No, they will be inverted. They will turn into inverted intervals of the same thing.
Because if we consider 3 to 4, 1, yeah. Then if we consider minus 3 to 4, we have to consider this 6.
Minus 3 to 4.
7, you're right. 7, you're right. 7, wait. It's not, we don't have 7. But we have. Wait. It's wait there.
Look, let's do it easier. So we do, look, 12 minus 3, 9, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, A. Yeah? And then, originally, you would have done 3 and 4, right? So you have done 1, 2, 3, it's a semitone, right? So now, we do.
Yes, now it's a 4th.
And now it's a 4th.
Yeah. We have another thing to put in the vector. Because we consider them all inverted and then put extra. We have an extra.
Yeah, but we have to see the effect in the overall quantities if we redo it like that. So maybe we'll still have the same amount, yeah, if we do it all over again. But well, I think for today is fine. So I will just bring you all these corroborations for the next week. Yeah, so we can move into compound themes. But the whole idea of analyzing this is that you do again another pitch class set. Yeah, but this time again a compound period, but trying to use less amount of notes, okay, and think more about the quality of the sound of the chords, something that I'm insisting on since a couple of lessons ago, yeah, because that's what the main, I want to deviate your attention into that, yeah. All right, and then we do another lesson of pitch class sets next time. We finish with it, we check all the exceptions, and we finish with pitch class sets. All right, so well, yes.
A new compound period with a new pitch class set, focusing on the.
Yes, and you write that on the shared document, okay?
Yeah.